we now discuss the solution of a problem from the section Mathematical Logic, and the problem is related to the negation of a given Boolean statement. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the second shift. The given question is negation of the Boolean statement P or Q in brackets implies in brackets negation of R or P is equivalent to. We are given 4 options. So here are the 4 options. Option A, option B, option C, option D. So we are given a Boolean statement. This is the Boolean statement given to us. And we have to write down the negation of this Boolean statement. Let's now discuss the solution of the problem in detail. We take the given Boolean statement P or Q implies negation of R or P. First, we write down, simplify this one, that means we write down an equivalent Boolean expression, which is a simple one. Then consider the negation of this Boolean expression, Boolean statement. Agreed. Now recall the equivalence of the Boolean expressions. And one of them is P implies Q is equivalent to negation of P or Q. So if you apply here, P or Q implies negation of R or P is equivalent to negation of the first, that is P or Q, or the second, that is negation of R or P. So that's what we have, right? So for the negation of P or Q, we apply De Morgan's law, and it says negation of P or Q is equivalent to negation of P and negation of Q. So we write down that. And the second one is as it is. As it is. Agreed. Now we apply a commutative law here. Negation of R or P. We want to write P or negation of R by applying the commutative law. So if I apply the commutative law, the first one is as it is, R, P or negation of R. Right. Now we apply associative law, thinking that this is one term and these are the 2 terms and they are connected by R. Agreed. So associative law we apply negation of P and negation of Q or P in brackets or negation of R. So that is the associative law for the R disjunction. Right. Now for this in the bracket we apply distributive law. So if you apply distributive law, negation of P or P and negation of Q or P. So we apply distributive law and we distribute like this. And the second one is as it is. And negation of P or P is a tautology, is always true for all values, truth values of P. So this is T, and when T, if you take T here, T and any statement, any expression is the expression. So T and P is equivalent to P. So this in the bracket it will be this one, that is this is equivalent to negation of Q or P in brackets or negation of R. Agreed. Now we apply commutative law because P, Q are in the same order we want. So that is we apply commutative law in the bracket, that is P or negation of Q or negation of R. So this is the simple statement for this, and which is an equivalent statement. So now we take the given Boolean statement and take the negation. The negation of the given Boolean expression is equivalent to the negation of what we have obtained here, that is P or negation of Q in brackets or negation of R. Agreed. Now this is equivalent to, the right hand side is equivalent to, we apply De Morgan's law. So that will be negation of the first and the negation of the second. So the negation of the first, P or negation of Q, and because this is R here, this will be and negation of R. And negation of R is R. And for negation of P or negation of Q, we apply again De Morgan's law. And for this, we have this double negation of R is R. So if you apply De Morgan's law here, this is equivalent to negation of P. This R becomes and negation of Q and R. This is R. And again now negation of Q is Q. So this is equivalent to negation of P and Q and R. So that is the negation of the given Boolean statement. Let's look at our options. Our answer, negation of P and Q and R, appears against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of a problem from the section mathematical logic. And this question is a very routine, regular, easy problem. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.